Today I'm going to be discussing improper integration, and what that is when you're trying to find an integral of a function which might be going out to infinity, in which case it might have an area of infinity. When you're usually finding an integral, you find it from a value to a value, and what you don't consider is if there is an asymptote, in which case the area might not exist. That's where you use improper integration, as well as if you're going from a value to infinity, you would also use improper integration. The next logical question would be how to actually solve the improper integral, and that would be with setting up a limit of a variable going to infinity of that variable in that integral. Also, if you had a two-part integral that you solve for, and one part diverges, then the entire thing diverges. Also, a basic rule is if you have something like this, and p was greater than 1, then it would converge. But if p was less than or equal to 1, it would diverge. Also, things to watch out for are asymptotes, and that includes functions like secant or cosecant, as well as functions with a bottom equal to 0. Like that. Now we're going to look at another example. If we look closely, we see that we have an asymptote at 3 and -3. And we see that 3 is inside our interval. So we're going to have to split up this integral from 0 to 3 from the left, and from 3 from the right to 4. Now, using u sub, we can integrate this and implement the limits. We use a different variable so we don't get mixed up. Now we can plug in all the numbers. And now we notice that as the limit approaches 3 here and 3 here, they all go to a very, very small number, close to 0. So what we know about the ln graph, which looks like that, is as a number approaches 0 from the direction, the positive direction, as this is an absolute value, it becomes negative infinity. And what we know is if one piece diverges, then the entire integral diverges. So this integral would diverge, or go to infinity. Now for another example, we're going to look at a trig problem. If we graph secant, we know it looks like that. And we see that at pi over 2, there's an asymptote, and we must split this up. So it'll go from 0 to pi over 2 from the left, to from pi over 2 from the right to pi. we can then set up limits accordingly. And we use our knowledge of tangent integrals to solve this. Now, not forgetting to set different variables for different limits. Now we can solve this out. The 0 term goes away as ln of 1 is 0, and we can evaluate this limit. Now we see that this one diverges, this diverges, so the entire limit would diverge, which makes sense as this area under the curve is infinitely large. Now, looking at these integrals, we can use our basic power laws, where we look at the power and determine whether the integral converges or diverges. Here we can see that the power is 5, which is greater than 1, so the integral converges. Here we see the power is 1, which is less than or equal to 1, so the integral diverges. Thank you for listening, and you can check out the practice problems I've provided below for extra practice, and goodbye.